and I'll get into that a little bit more, but basically it goes from our flat content-based standards that they've been on, that we've had for years and years, to these three-dimensional NGSS standards, and what the difference looks like at the grassroots level on the ground floor. And the topic that I'm going to show you concretely is through the respiratory system. So, these are the Livingston Public School System's standards for science right now. We haven't actually adopted NGSS, so I'm in a unique perspective in which my content looks like this, but I still want to make it three-dimensional with the practices and the cross-cutting concepts that NGSS is as an advocate for the framework and the standards. And I am looking at this standard right here is what I'm meeting for content. And I don't know if you can see, but these are national standards, Montana standards, and this right here is the actual district standard. So it's investigate body systems, basic cell structures, and function. And respiratory system is on there. So I'm supposed to investigate the respiratory system. That was my standard. And here are some resources for the respiratory system, just so that we can kind of look at this. This would be the background information that many students would have, either through research, textbooks, however you would present that in your classroom. But everything would be content-based at this point. And here are some valid lessons for content standards on the respiratory system. Paper models happen all over the place when we're looking for content standards. And it's not that this type of teaching makes a bad teacher. This is an evolution, and it's really revolutionary. There have been a lot of changes in science, but this three-dimensional look at how we do science in a classroom is completely different than anything we've ever seen. So if you scour the internet for models of the respiratory system, you will see a lot of this. And I mean, how many of you have made a paper model of something in your science education? Cell model, maybe that was even three-dimensional with some food or things like that. But what we're going to look at is we're going to critique where we've been and the evolution of the pedagogy, especially in my classroom, and I'm going to use myself as an example, and which is so be easy on me. A little look at my growth instead of where I started. So what type of critical thinking do these lessons initiate? I mean, this doesn't look that much different than the slide before. So if we'll go back to the slide before, we have the book, the textbook, and then the project. Did I create any sort of critical thinking within my students? Did they go beyond anything else? We'll go to the next slide. So, for this type of standard, which is one-dimensional, meaning that it is only about content, the word investigate is in there, but my students investigated they investigated the textbook and made their own little replica of the textbook. So this is a one-dimensional standard. It is all based on content. And I met that standard. And I met it just fine. And it was valid. But it wasn't great. It wasn't great. So we'll go to the next slide. The next generation science standards have this logo on them. And it's really a nice visual of it being a three-dimensional piece. Without one of those sides, it collapses. So you need all three of those pieces in order to be able to have a three-dimensional lesson. So you have one of these. Everybody has a card, correct? Mm-hmm. Okay, so on the card, you can see these different colors represented here on the card. Blue, green, and orange-ish. Okay? Our disciplinary core ideas would be the content. That would be the content. And that's what I was coming from. But then there are two other pieces to that, cross-cutting concepts and let's call it the practices. So I needed to change my lesson, not in content, because in Montana we haven't adapted that or adopted those yet, but I needed to keep my content and still make that three-dimensional. And that's what it looks like in Montana for us right now. We'll go to the next standard. This is the standard for 5th grade, where I teach. And my what I'm going to do is meet some of these standards with the cross-cutting concepts and the engineering practices added onto it to make it more three-dimensional. And you'll see that my content doesn't end up being super strong because I'm following another standard with the three-dimensional model. And we'll get to that. So what I did instead was, how am I going to create some critical thinking for my students? And I gave them a straw, 2 balloons, and a water bottle, some rubber bands. And I said, make me the respiratory system or a portion of the respiratory system. And I didn't tell them what to do, and I didn't tell them how to make it. So they took their materials, and it was homework, actually, and they thought that it was the best homework ever. But that was a great thing because it was one of the first things that we did this year for science. So they were able to go and try this on their own, take as much or as little time as they wanted, and not be influenced by what somebody else was doing in the classroom. And it ended up being a really positive experience. And since then, I've been giving them science to take home with inexpensive materials. So we have a lot of different variations on the respiratory system model. We can kind of flip through those and see students. A lot of different things here. And those look much different than the paper models in the book. I love that one. I have done it. This was some of their first notebooking experience as well. They haven't done it in previous grades, and this was the beginning of the year.
How did they learn about the respiratory system now? Did you teach it?
We had background information. Yep, absolutely.
So you're having them communicate how they came about what they did. That's
Mm-hmm.
great.
How'd you come up with the ideas for the take-home project?
I Googled respiratory system models, saw what some of them were made of, and then didn't tell them that I had done that and gave them the materials.
That's awesome.
So after they had completed their model, they had to then look at their model critically and decide what it correctly represented and what it did not. And I found with looking at models, having the students really dissect, this is how my model is not like the real thing, is just as valid as making the model or talking about how it is like the real thing. So they filled out a Venn diagram on their notebooks. Filled out a Venn diagram on their notebooks about what their model had, what they had, and this section right here would be what was represented correctly. Or, I don't know if I used correctly. This is a video. One gentleman decided that he was going to communicate digitally. So we played this for the class, and this gives you an idea of what sort of thinking was happening with the students. So.
It might be a little quiet, so we didn't have a microphone for the, so hopefully we can hear.
This is my model of working on, you have your trachea, your ribcage, which is this ball, you have the lung, which is the balloon, and then you have your diaphragm, which is this, the breathing in, being back in, pulling down like the diaphragm muscle does, it pulls down on your lungs, and then you're breathing back in, things in my face. And we get larger, into your body, and then when it out, it shrinks it, pushing out the carbon dioxide that you don't want in your body. Pros about this, it has working on it, it expands and contracts. And then cons, it does not have 2 lungs like I wish it did. And then we have the diaphragm is not an actual something pulling down. It's not like an actual muscle. Like, I don't know. So yeah, this is my working on. Thanks.
All right.
Did you actually give them each one a model?
And I just had them bring it in by a certain amount of time. Just just a
Right.
water bottle. And I did tell them to actually cut the bottom of it off for the rib cage, but I didn't tell them anything else. We could go to the next slide. So let's critique where I was and where I am now, or where I'm going. We're not quite, there ever. But if I'm making that paper model and I'm looking at the content for the respiratory system, my disciplinary core ideas is that content. Do you see anything in the other colors, in the other sections, that I accomplished through teaching that content?
The systems and system models.
Systems and system models. Is there anything else?
And
This is for the paper model.
my apologies.
The paper model. Mhm. This is for the paper model. Did they ask questions or define problems making that paper model? Did they develop and use a model? Develop
They didn't
being the
develop it.
keyword.
They just copied it.
They copied it, that's right. And did they plan or carry out an investigation? Did they analyze or interpret data? Did they use mathematical or computational thinking? Did they construct explanations or design solutions? Did they engage in argument from evidence? Did they obtain, evaluate, or communicate information? So if I look at the practices, I have removed that piece from the three-dimensional model of the NGSS. Cross-cutting concepts, patterns, cause and effect, scale, proportion, and quantity, systems and system models, maybe, but it's more of looking at a book and writing it down. Structure and function, energy and matter, stability and change. I fell really flat. Fell down hard. But this is what the standards were. They were one-dimensional. I met my standard. And it's been a valid lesson for years. So I have to be easy on myself now that I'm different and not look back and kind of cringe. It's a growing process.
Sure.
It's a growing process. So with the new lesson, same content. Did I meet the content standard about the respiratory system?
Sure.
Okay. On the practices, did they ask questions and define problems? Did they develop and use a model?
Yep.
They did. Did they plan and carry out an investigation? Maybe. Analyze and interpret data? Not so much. Mathematical and computational thinking? Not so much. Did they construct explanations?
Yes.
And they didn't design solutions, but now, growing again, I could go back and say, look at that Venn diagram. And something that's on the me part, that's not on the model, could you change your model in one way? Then they would be designing a solution. And that would be valid there. Did they engage in argument from evidence?
I think they did.
They looked at their Venn diagram and they did discuss it in groups. So that touches on that. It could have been a lot deeper, absolutely. Did they obtain, evaluate, and communicate information?
Yeah.
Absolutely. Cross-cutting concepts, patterns, cause and effect,
Yeah.
scale, proportion, and quantity, system and system models, structure and function. He talked a lot about the diaphragm muscle and how that works and how it's needed in order for the lungs to expand and contract. Those conversations never came up with the paper models. And some of the models on the textbooks don't even include the diaphragm muscle. So, energy and matter, stability and change. It's not really realistic to think you're going to hit every single thing, especially if you're going to gain any depth. But for a three-dimensional lesson, I have touched on a lot more things, or a lot of the topics on here on the 3 dimensions. You see the difference? Okay. Yes?
Just a question, do they all receive the same materials to start with?
Yes,
Did you allow them to use other materials besides those?
They
Okay,
did.
I was curious what the variants and the types of models that they produced. Did that, if they were to add them up, did they all look similar or were they very different?
both.
Yeah.
I would say both. Some of them cut the straw in half so that there would be two. Some of them let one straw go and then cut the other two in half, cut the other one in half. Some of them used one balloon, some of them used two balloons. Some people put the balloon on the bottom. They probably Googled that, but that's okay. They still had to think about how it worked to use the diaphragm muscle. So they were very different. Some of them just had a straw going into a balloon that they would blow into, and that was it. And that was okay, because they still had to look at the model and think about it and critique it. So they were able to get to the other three dimensions, or all three dimensions on their level. Does that answer your question?
Yes, thank you. And also I was wondering, maybe I'm getting ahead of myself, the assessment you used to evaluate their understanding, did you do a different kind of assessment than you had in the past?
This was formative. This was formative. And at the end, we've typically in 5th grade, what the pedagogy has been is to look at the models themselves. I wasn't looking at the model itself, but I was looking at the critique of the model in the notebook instead this time. So we can go forward. So now I'm looking at this as my content, but you need to replace this with the content that I'm required to teach in Montana right now. So my content's here, and the way that NGSS is set up is that you can decide which one you want to go on, which different dimensions that you would like to do. But they also give you a guide, so that you're not having to think about every single unit, how you're going to connect those things. The cross-cutting concept is system and system models, and the practices is developing and using models. So through this, you can see how these are a lot more, the standards, the way that they're written are a lot more three-dimensional than just the flat concept, just the content. So, let's see.
So Montana, actually, you haven't adopted these yet?
We haven't adopted them in Montana.
But you're taking like a baby? Is this your district's choice to?
This is a grassroots movement to show the higher kind of powers in Montana that teachers would like to adopt NGSS.
That's great.
Yeah. So that's what the project. Would you?
Yeah.
Is that a way you would sum it up? Yeah. Okay.
Who started the project? I guess you.
Yeah, we had the Math Science Partnership Grant, so it's a collaboration of three universities and the districts. And so really, and Montana is a tiny, large state, so we've all been involved together with each other. And as we were going through the writing and it became clear that we weren't going to adopt, we said we have to get this off the ground anyway. So the way to do that is have enough forward momentum on the positive side that any of the naysayers on the other side would just be flattened. So we can just keep steamrolling, yes. And the teachers themselves taking ownership of the NGSS and being able to describe how easily they can convert the Montana standards into the NGSS standards really has been helpful, because now they're not even thinking about it. They're just saying, well, we're meeting NGSS and it's a higher standard than our state standards anyway, so we're okay. And they're just not even worried about it. I would say those that have been working with us aren't worried.
By any chance, will you be posting your PowerPoint?
Yes, it is. It's already uploaded, so you can download it right now.
So in looking at the standards as a teacher, there's a summary of what everything is at the top, but then you have your 3 dimensions. And the standards are grouped together in almost units. And for 5th grade, I would have 5 of these to cover throughout the whole year, which means that I could really get into some depth. And looking through all 3 dimensions is very powerful, but this is amazing. This is, Common Core listed for you. This shows you where to go. And I think for administration and for a lot of teachers, they think I don't have time for science in my classroom. I have to meet all of these other things. Common Core is huge. can do it all at the same time.
Mm-hmm.
Do it all at the same time. And we're looking at very in-depth Common Core connections for both math and English language arts. And science is applied. Both of those things apply. Yes?
Since you mentioned this overlap with the Common Core, so how many hours of science do you teach?
How many hours of science do I teach?
Yeah.
I teach 3 hours of science a week, but I would compare it to a flipped classroom, almost, where those 3 hours of science, students are doing science. The research, reading, writing, and math that goes with that, I'll do that in language arts and in math. So how many hours of science am I teaching a week? A lot. But on the schedule, it's about 3 hours. It's about 3 hours. But we use the research portion in those other places. And I'm supported in doing that right here. So if we could go to the next one. These are online. If you Google NGSS and Common Core Venn diagram, these are what comes up. And it's people who have looked at the practices. I think in English language arts they're called capacities. So the capacities in language, math practices, and science practices. And they've decided that this is how they all fit together. I disagree. This is how I see them in my room, fitting together. And I have some cultural perspectives up here by itself in English language arts, but that really depends on what you're teaching. That could be blended in as well. But I had a colleague at my school who stated it so eloquently. She said, "Why are we looking at all of these separate things? This is driving me crazy. Let's look at what they all have in common. Let's look at the lens of what everything has in common to help us teach these things." And I thought, you know what? Absolutely. This is what they have in common. So I can teach all of them together here. Math and science, English language arts. That's how I see them coming together. Let's see. I think that is it. Does anybody have questions at the grassroots level, at the administration?